Hi everybody. This is a second video lesson on factoring where we're going to practice with factoring quadratics where the leading coefficient is not 1, where a number other than 1 is in front of the x squared term. Okay, so I'm going to show you 3 methods here. I'm going to end up focusing the most on the third method for this recording because it's the new method we discussed, and I think it really is helpful in factoring more complex quadratic. So we're going to focus more on that, but let me show you all 3 to begin. When we're faced with a quadratic that looks like this, when I look at this and I see that I have a 5 and a -6, this one shouldn't be too hard to factor because the only factors of 5 are 1 and 5, and the only factors of 6, if I forget the negative for now, are 1 and 6 and 2 and 3. It's not that many different numbers to experiment. So through trial and error, it should not be too difficult to find the 2 binomials I'm trying to factor this into. So if I start with this term, in order for me to have the first terms, because it's the first terms, remember, in FOIL, I do first, outside, inside, last, and those first 2 terms in the binomials have to equal this here. So the only way I can factor the first 2 terms are 5n and n. There's a hidden 1 there, of course, because 5 times 1 are the only ways I get to 5, and then n times n is how I get to n squared. So that part is done for me. So now all I'm experimenting with are 2 numbers that when multiplied will give me -6, but when I use the FOIL method will give me -7n as my middle term. So let's experiment. I know if this is negative that 1 has to be negative and 1 has to be positive. So let me try a -6 here and a +1 there, because -6 times 1 will give me -6 and it will give me my last term. And I know 5n times n gives me my 5n squared. So all I have to do now is FOIL it and see if I get to -7n. Well, 5n times 1, which are my outside terms, gives me 5n, and -6 times n gives me -6n, and when I add those together I get -n, and -n is clearly not -7n. So that didn't work. Those 2 factors are not going to do it for me. Oh, I'm having trouble with my eraser, sorry. Are not going to do it for me. So let's try again. Why don't I try my 2 and my 3? +2 maybe and -3. So 2 times -3 gets me -6. If I do my outside and inside terms, I get -5n and 2n, and that gets me -13n, and that didn't work. So that's no good. That's not -7n. Okay, so I'm going to erase that. But let me switch them around. Let me do my -3 here and my +2 here and see what happens. So 5n and n, 5n squared, -3 and 2 is -6. So I do my outside and inside, I get 10n, I get -3n, and I get 7n, and I am so close. So all I'm going to do now, because I feel like my numbers are in the right place, just my signs are wrong, if I switch these and do a plus and a minus, 5n times n is 5n squared, outside terms -10n, inside terms +3n. When I add those together, they do make -7n, and then 3 times -2 is -6. So I have, in fact, successfully factored that quadratic into these 2 binomials. And that wasn't too bad. It wasn't too much trial and error because there weren't that many factors to deal with. Another way I've seen people do this, so this was one method. A second method I've seen is kind of a crisscross method, where you take this first one, and if those are the factors, 5 and 1, now I'm going to experiment with my other factors here. So if I tried like -6 and 1, you do a crisscross. 5 times 1 gives me 5. -6 times 1 gives me -6. When I add those together, I get -1, and I want it to be -7. So that didn't work, so I would erase. And try some other terms. Well, how about 3 and -2? When I add those together, I get -10. When I multiply those, I get 3. -10 plus 3 gets me -7. That, in fact, is what I'm looking for here. So this worked. The crisscross worked. I got what I needed. And then in this crisscross method, you then write your binomial by writing across. So this one would turn into 5n plus 3. Because I put the factor there, and this one would turn into n minus 2. And you can see that this method matches that method, and I have the 2 binomials. But let's talk now about the third method that we discussed in class, which I think is a little less trial and error. Okay, if you'll recall, when we write a quadratic, the standard form is ax squared plus bx plus c. And in this situation, I'm going to be multiplying my a and my c, my term in front of my n squared and my constant at the end. So I would multiply 5 times negative 6, and I get negative 30. That's what the first step of this method. Now, when I get negative 30, then what I'm looking for is factors of negative 30 that when multiplied will give me negative 30, but when added together will give me this negative 7 term. So I'm going to start doing that. Once again, since this is a negative and this is a negative, I'm going to need two factors where one is negative, one is positive, but the absolute value of the negative number needs to be larger so that I get a negative number when I add those terms. So in this case, I can start by trying, negative 30 and 1, but I can see when I add those I'm going to get negative 29, and that's clearly not negative 7. How about negative 15 and 2? When I add those together, that's negative 13, and I'm still not at negative 7. How about negative 10 and 3? When I add those, what do I get? I get a negative 7, and that's what I want. So I have found the two terms that I want here. And what I'm going to do in this method is just rewrite this quadratic in a slightly different form, but still meaning the same thing. So I'm going to bring down my 5n squared, and then I'm going to use these two factors, negative 10n plus 3n. And you should see that that is the same as negative 7n. Negative 10n plus 3n is the same as negative 7n. So I haven't changed the value of this quadratic. I've just written it differently. And then I bring down my minus 6. And then in this method, what I do is I group the first two terms and group the last two terms, and I'm going to GCF factor them. So I'm going to look for the greatest common factor here, and I can see that that's 5n. So I'll pull my 5n out, and what's left is an n minus 2. And then I'm looking for a GCF here, which is 3. So I'm going to pull my 3 out, and I'm left with an n minus 2. And then what we notice in this method is that this binomial is the same as that binomial. I have the same binomial in the parentheses. So then I'm kind of doing a reverse distributive property. I have 5n plus 3 by bringing these two terms together times n minus 2. And that is my factored quadratic, and you can see that it matches method 2 and it matches method 1, and it's just yet another way to factor a quadratic. Now let's get a little more practice. This would be one that I'm really just going to show the new method on this, because this would be a little more complicated. I'd have to be looking at 1 and 10, 2 and 5 in various combinations, along with 1 and negative 15, negative 1 and 15, 3 and negative 5, negative 3 and 5. That's a lot of combinations. That's a lot of trial and error. So let's use method 3. Let's use the new method. In the new method, once again, we multiply the a term by the c term. So we multiply 10 times negative 15, and 10 times negative 15 gives me negative 150. And now what I am trying to do here is find the factors of negative 150 that when added together will give me negative 19. So once again, since this is a negative and this is a negative, the larger absolute value is going to have to be negative. So let's start. Negative 150 and 1, I'm not even going to add that together. That's way off negative 19. Negative 75 and 2, that's negative 73, not even close. Negative 50 and 3, that's negative 47. How about negative 30 and 5? No, still not there. That's negative 25, but I'm getting closer. How about negative 25 times 6? Negative 25 times 6 is going to give me that negative 150, but when I add those together, look what I get. I get negative 19, and that's what I was looking for. So these are the two coefficients that I'm going to use to divide up this negative 19x. So I'm going to rewrite it as 10x squared minus 25x plus 6x, because negative 25x plus 6x is negative 19x minus 15. And then we just group and factor. So we'll pull out the greatest common factor here. That's 5x, and what I'm left with is 2x minus 5. And then here I'm going to pull out a 3, and I'm left with, luckily, 2x minus 5, which means I did this right. I have the same binomial in here, so I rewrite this as 5x plus 3 times 2x minus 5, and I have factored that quadratic. Now you might ask, Mrs. Walsh, why did you do negative 25x plus 6x instead of 6x minus 25x? Well, let's try. If I do 10x squared plus 6x minus 25x minus 15, that means the same as this, so it should work, right? Well, let's try. In this case, the largest factor I can factor out is 2x, and I'm left with inside 5x plus 3. And what can I factor out here? Well, a 5. So I have this negative out here. I'm going to factor out the 5, and I'm left with x plus 3, because negative 5 times 3 is going to give me negative 15. And look, I'm sorry, 5x plus 3, because negative 5 times 5x is going to give me the negative 25x, and negative 5 times 3 is going to give me the negative 15. So look, same factors, same binomials there. So this is 2x minus 5 times 5x plus 3, which is the same answer here, just written in a different order, which doesn't matter. So the message here is, doesn't matter what order you put those two in, it should work. All right, let's do one final quadratic. In this case, we have to remember rule number 1. Don't forget rule number 1. What is that? Do I have a GCF? And I do. So let me make my life a little easier and make this 2 times 10x squared plus 17x plus 3. And now I'm going to use my method. So with my method, I'm going to multiply my a and my c. So that's 10 times 3, which gives me 30. And I'm looking for factors of 30 that will add up to 17. 30 and 1 won't do it. 15 and 2, yay, I got it quick. So I'm going to divide this into 15 and 2. So I'm going to leave my 2 out here. And here I'm going to rewrite this as 10x squared plus 15x plus 2x plus 3. And everybody agrees that that's just the same as writing 17x. I just divided it into 15x plus 2x. Now I'm going to group them, and I'm going to make this a bracket. So I'm going to do 10x squared plus 15x as my first grouping, and then 2x plus 3 as my second grouping. And I'm going to see if I can GCF factor those. So that would be 2 times, I'm going to pull out a 5x here, and I'm left with a 2x plus 3. And then I have nothing to pull out of my 2x plus 3, but that's fine, because look, I have the same binomial in both instances. And what do I really have here? You guys know there's a little hidden 1 right there. Okay? So now when I rewrite this, I'm going to write it as 2 times 5x plus 1 times 2x plus 3. And I can test and make sure this works. These two are 10x squared, my outside term 15x, my inside term 2x, that gets me 17x, and my last term's 3. It works. And I really don't need these brackets, so I can just rewrite this as 2 times 5x plus 1 times 2x plus 3. So I really do think that this method really helps, especially in these more complex quadratics, because it takes really a lot of the guesswork out. We're still doing some guesswork over here when we multiply our a and c and find the factors that will give us the middle term. But other than that, once we get to this step, the guesswork's really out of it when we get down here and we're able to factor. So you guys, once again, you know yourselves. You know what makes sense to you. You've got to use the methods that are going to work for you. So when it's a more simple quadratic where you can easily see that, like we had back in there in the example where, you know, the leading coefficient was 5. 5 only has factors of 1 and 5. And using trial and error or the crisscross method may really be the quickest and best way to do it. But if you're struggling with factoring a quadratic that has a leading coefficient that is not 1, this method actually I find very helpful. So hope this was helpful to you, and I'll see you guys tomorrow.